Hi and welcome to TRX Bench. Well, today I have really a nice and interesting video for you. I have here a broken microphone. Ha, you think that is boring? Oh, I don't think so. We should talk a little bit about the used microphones in ham radios, and we should talk a little bit about this always used Electret microphones which are built in these hand microphones and sometimes also in stand microphones. So how do they work, and well, how can we troubleshoot a microphone like this if it don't work? This microphone is really broken, so it came in, and I got the fault description that the audio is not present. So that means we can obviously press the PTT, and that is working, but there is no audio, and there starts all about Electret microphones. So let us look a little bit into that technique, and let us look how we really can troubleshoot microphones like this. And finally, let's simply look what's wrong with this. What is it? It is the ICOM HM151 microphone, and this microphone doesn't work. So let's figure out what's going on, and besides that, let's learn a little bit about microphones. Alright, and here is our HM151, and well, first of all, of course, we have to test it if we have the same finding as we got it from the fault report. But it is interesting, because that is what we want to talk a little bit about, is this Electret capsule, which is very often used in our ham radio microphones. And if you really watch through this hole, you already see barely that there is our microphone capsule, and you see that it must be really a little tiny device which is our capsule, which is responsible for producing our audio to bring it through the signal path in our radio, and that our audio will be received at a distant end. And just to get an idea how tiny these capsules are, here these are Electret capsules, and they are very, very tiny. Here you can compare it with the well-known lithium battery CR2032, and you really see how tiny these capsules are. And these are, by the way, as well, very thin. So this is really a special capsule, but this might give you an idea what we are talking about. Well, we always hear other radio operator talking about dynamic microphones, and dynamic microphones are called as the most best technology which is on the market. And well, for instance, here this is a dynamic capsule, and you know, this is really a crappy one. So it does not automatically mean that a dynamic capsule is better than an Electret capsule. So, you know, it always depends on the build quality and the knowledge which is behind it, and the technique which has been used in production and development, and so forth and so forth. And of course, everybody knows these Heil microphones. And this is the gold Electret, and it is especially made for ham radio purposes. So we all know Bob Heil is a ham operator himself, and so he has as well a line of Heil microphones. And you know, this dedicated ham microphones are really first class. So these are high performance dynamic elements built in, and therefore that is really great. But does that now mean automatically that our Electret capsules are crap? No, not really. So it is the same like with this dynamic microphone. You know, it always depends on how they were built and developed, and what the production procedure was. So for instance, this little Electret capsules are really high quality, and they really have an excellent sound, and therefore no, it really always depends. But I mean, you know, these Electret capsules have a bad reputation because they were built in very low quality, and therefore they were cheap, they were built in low quality, and therefore the audio experience is simply bad. So, you know, that is what you always have. You get what you pay for, and that is exactly the same with this crappy dynamic capsule. So you get what you pay for, so this is simply crap. But what is now Electret capsule, and how does it work? Well, basically Electret capsule is more or less a new form of our condenser microphone. So here in the picture you see a condenser microphone, and yeah, as we are talking about condenser capacitors, we may understand that we need a certain voltage to get it into work. Already very early in studio technique, broadcasting technique, this condenser microphones has been used, and this is an example, a very early model. So you see here a tube which is at least the amplifier for this condenser microphone, and you see here the condenser plates, because more or less it is not more than a plate condenser. And well, let me see, I have another picture for you that you better understand what's really going on. Basically it is this here. So you have two plates, and you have air in between, and now you put a voltage to the plates, and now if there is voice coming to these plates, then finally the plates are moving a little bit, and therefore the capacitor is changing, and that means that the voltage is changing as well. And maybe this picture shows it a little better. So finally we have here our capacitor, so a plate capacitor, and we get voice here onto it, and we have here our voltage, so-called phantom voltage. So all the condenser microphones are using phantom voltage most of the time, using 48 volt, and then when these plates are moving just a little bit, you can pick here your signal, and then you can put it to a buffer and a preamplifier, amplifier, so that you really can use this. And as I said, this microphone types has been used very early in studio technique. Broadcast station was using it, and these microphones, if they are made of high quality, are very good and producing a very good sound. And here you can see what I mean. So this here is a studio microphone input, and depending on what kind of microphone I use, a dynamic one or a condenser microphone, I can switch in here my phantom voltage of 48 volt, and so I can decide will I use a condenser or a dynamic microphone. And now, how does a dynamic microphone work? And well, this crappy dynamic microphone is not very good, but anyways, it is working like a dynamic microphone is working. And you barely see here a coil, and in the middle here we have a magnet, and both of these components are able to produce an AC voltage. And here you can see what I mean. So this is basically a dynamic microphone, and we have a magnet, and we have here a coil, and if the sound wave comes here to the microphone, then the magnet or the coil, it always depends on the used technique, is moving. So maybe the magnet is here moving through our coil, then an AC voltage gets induced, and we can of course pick our signal here from the coil. So with a dynamic microphone we do not need phantom voltage, so we really simply only need a coil and a magnet, and then we are able to induce a voltage, and that is what we need to get our audio. And now, after all, what is finally Electret microphone capsule? And that is here the diagram of Electret microphone. So what we still need is a voltage which is supplied to the capsule, and in our capsule we have most of the time a FET transistor as impedance converter, and you see we just feed here a DC voltage to our capsule, so we do not see finally our transistor, so we only see the both pads on the capsule where we connect our wires to. But finally we need a voltage, and the advantage is compared to a condenser microphone, we do not need 48 volt or even a higher voltage, so we need a voltage between 1 and maximum 10 volt, and then we are able to drive an Electret capsule, and then we can pick, of course, behind this capacitor we can pick our NF signal. And of course we need here a capacitor as a blocking capacitor that no DC voltage is able to get somehow into our AF signal pass. So therefore this is more or less a DC blocking capacitor, and we have here our supply to get it work. And of course if we look here at this Electret microphone, we only see this both pins, and one is ground and the other one is the supply pad, and as well our pad for taking the or picking the NF. But how does it look like if we would open such an Electret capsule? And that might be the interesting picture, because you can see here really the little FET transistor, and then you have here our Electret component, which is then giving the voltage to our FET, and the FET will do the impedance matching for us, and then we can pick our signal as already said. And this might be interesting for you. On January the 14th of 1964, we see United States Patent Office, and here we have a first patent of a foil Electret microphone by GM Sessler, I believe it is called. And if you're interested in this, you can find it on Wikipedia, and there you can read the original text. So after all, we can definitely say that Electret microphone is another form of a condenser microphone, so maybe a more advanced technique. No, not really, because you know we have really still high class condenser microphones, and well, these Electret capsules are a different kind, which is used in mobile devices because they are small. They do not really consume a lot of power, so you can do it with battery operation, and so you really have a lot of advantages why to use Electret capsule. But as it is always, and as I already said it before, if it is of low quality, then of course it is really crap and you cannot use it. But really a lot of Electret capsules which are on the market are really first class and have really a great sound. Okay, but now back to our microphone, which is not working, and we want to look now how to troubleshoot. We have now basic knowledge how it works. So first of all, you can test your microphone, of course, when it is connected to your radio, and when you press your PTT, then you can see what your transceiver does. And if it goes into transmit, you know that your PTT is working. And then when you talk here into your microphone, maybe the easiest way is to do it on SSB. And when you are sure that your radio is working just fine, then you should see coming up your output power by talking to the microphone. So therefore that is a way how you can test it at home. I will do it here a little bit different. Well, here in the lab I have a little microphone test set. As it has happened here with this microphone, I have the microphone, but I do not have the radio, and therefore I have this little test set. I mean, what you get on the market, for instance, is this here. This is a Superstar let me see. So that is a Superstar T747 microphone test center, and as you already see, this is more for CB radios, but I mean, it is basically what you need. I mean, you have here the different sockets, and this is here, of course, for CB radios, but I just made a little extension here, so I put here another plug here into my test set, and I'm now able to connect here this microphone, how can I say, especially made here for this Western plugs. So this is homebrewed. I have here now 3 connected internally for ICOM, Kenwood and Yaesu, and thus I'm able to test microphones like this, because as you see, this is this Western socket, and therefore I plug it here into ICOM, and it is internally wired up for ICOM microphones using this Western, this Western plug. And of course, if it comes to normal microphone connectors, then of course you need something like this. So this is homebrewed as well, and again it is Yaesu, it is Kenwood and ICOM, and that is made in the same way. I can directly here plug it to my test center. Oh, that sounds great. To the test center, and then I'm able to test microphones and can do my diagnosis. So basically it is nothing else than an audio amplifier here inside, and I can test more than one step. So first of all, I can test for the PTT, and you see, if I press here the PTT, the red light comes up, but we have other microphones where we do not have the indication here on the mic, so therefore this is informing me that the PTT switching circuit is just working fine. And if I would have connected here an CB microphone, then you would see the RX LED on. Let me see, I have definitely here an Albrecht microphone, for instance, and we can check it. Yeah, this is here a little Albrecht, which is the same like this Magnum here, and when I plug it in, you directly see that the RX LED is on, indicating that this circuit is working, because you may know that if you have a CB radio, you get your speaker always switched through your PTT switch, and that is why you need to see if your speaker connection, which is done in the microphone, is fine, because otherwise you wouldn't hear nothing on your CB radio. So therefore this RX light is very important. And then additional to that if I press the PTT, you see it is switching. And when I now talk here, 1 2 1 2 1 2 test test test, I can directly test if this microphone is working, and I get a rough impression on how this microphone sounds. 1 2 1 2 1 2 1 2 test test 1 2 audio test 1 2 1 2. So that is really a neat unit, and you already have information how your microphone is working. Okay, so now back here to our ICOM microphone, and we have already seen that PTT is working, but talking here into our microphone and you do not hear nothing. So the microphone is obviously completely dead, so we do not have audio, and yeah, so we need to figure out what's going on here. And therefore, as always, let's have a look in the service manual, and you see ICOM has a known service manual for its HM151, and that is what I have here. And when we go through, yeah, we have our parts list, and we have all the information how to assemble this microphone, and we have our PCB layouts, and of course we have here our wiring diagram. And when I now directly go here to our circuit, and I mean, of course, we have here a lot of functions on this microphone, all these buttons here, which are very useful, but we do not have a problem with all the buttons, so we do not need to talk about this IC, which is responsible for organizing all the function which this microphone is able to handle. We are only interested here in our microphone section, and there we find what we have already talking about. Here we have our Electret microphone capsule, and now we already find what we have discussed earlier. First of all, we see that we get 8 volt here from our microphone socket in the radio, and this 8 volt gets directly here to our microphone capsule, and you see we have here some resistors, and then it is directly connected to our capsule. And remember, inside this capsule we have a little FET transistor for doing the impedance conversion, and then you see our audio signal pass, and you see here our DC blocking capacitor, and then you see the audio leaving our microphone to or into direction of our radio. And that is all what we finally need to know. I mean, okay, here is a Zener diode, so that is used as protection, and here is a little capacitor for reducing some noise and such. And this voltage divider here is for providing the requested current or the requested voltage. Remember, we only need a voltage of about 1 to 10 volt, so that depends on the capsule itself, but that is all. So what we really need to check is first of all, is our voltage present, and we know already that there is a voltage present here in our mic, because otherwise we wouldn't get this indication here, and that is very clear if we see what we have here. So here we have a Zener diode with a transistor, so this is for voltage needed here for, yeah, that is for the IC. Let me double check. Yeah, so that is the supply voltage for the IC, and all our LEDs here. So you see here the LEDs are directly connected to our 8 volt, and if this 8 volt here wouldn't be present, then our LEDs simply wouldn't work. So therefore we can be sure that everything is fine with our voltage, but anyways, we should of course check it here at R39 and at least at R40, and then directly at our capsule, and the other side is directly connected to ground, and that is what we can check as well. And then already then we should be able to pick our signal here normally behind our DC blocking capacitor, and we can watch it with our scope if the impedances are somehow okay, but with the FET inside we should be able to pick a signal here, and then we can follow it until our pin 6 of our Western connector, and then we know what's really going on. So that is basically all what we need to know here about this little schematic. Maybe it is interesting, this C30, which is the DC blocking capacitor, has an impact on the audio. Depending on the value of this capacitor, your voice may sound with more highs or with more basses, so you can finally adjust your voice a little bit with this DC blocking capacitor, because you know, the signal needs to pass through, and depending on its capacitor, it has a different impact to different frequencies, of course. Okay, and that is not very difficult. So we only have 2 screws here in our microphone, which of course we have to take off, and then we can lift it up, and we are already in. And here you can see the whole PCB, and most of the electronic which is inside here around this IC is for all the functions this microphone has. But as we know, we have no problem with this. We only have a problem with our audio. We just want to investigate our audio signal path. Well, and observing the board, the PCB, I really wonder, because if you watch here very carefully, do you already see what I see? I mean, just maybe pause your video and watch the PCB, and then maybe you see what I already see. And okay, let me show you what I mean. So everything here is SMD-Technik. And then we have here, and that is most likely a capacitor, which is not SMD. And I could bet that this capacitor is not the original one. And what I've seen as well, I don't know if we can see it here through the camera. I mean, this here is a connection for our Electret capsule. So these are the both terminals. And there I can see some flux residue. So somebody already was in and has changed maybe the capsule to a higher quality one, maybe, I don't know. And I could bet that this here is our DC coupling capacitor, where we know that not coupling capacitor, sorry. Oh yeah, well, maybe it is a coupling capacitor for our AF, but it is a DC blocking capacitor. I would call it more that way. So I could bet that this here is our, what was it in the schematic? Let me double, yeah, it was a C30. I could bet that this here is a C30. So we have our PCB layout. So let's have a look on the layouts. All right, so here we have our C30, but now we are interested in our PCB layout, and let me see. This one looks pretty nice, so let me see what we have. And yeah, yeah, I think let me zoom it in a little bit, then it is easier for you to see. And that is the area where we found this yellow component, where I was guessing it is a capacitor which is not normally here in the circuit. And you see, normally the C30 is SMD component. So I believe that somebody has changed this capacitor simply due to the fact that you can change your voice. So depending on your own voice, depending on the used capsule and the used capacitor, you have a different sound. And as I already said, you can influence with the C30 your audio, and that has definitely happened here to our capsule. Yeah, not to the capsule, to the capacitor is what I meant. And so you clearly can see when I go closer. Yeah, you already be able to see. And if you are looking on a real big screen, you may already see that these are not really good solder points, so I can only barely see it through my camera here in macro mode. I'm not able to see it with my eyes, but here through the camera I believe that something is wrong here with the solder joints here, but I'm sure that you can see it even better on your big screen than I'm able to see it here with my eyes. So that is first of all suspect, and we have to go ahead, and we have to have this here in consideration. So first of all, let me simply take out here the board completely out of the housing, so then we can watch both sides, and we can do our first probing. Okay, and here we have our PCB out of the housing, and when I flip it over, you can see here our Electret capsule. So this is nicely soldered in here, and well, the first what we can do, and that works very often with audio, we can do a first finger test. Do you know the finger test? You simply poke around here. Don't know if you can hear it, so let me increase the volume. And do you hear the hum? I hope that is. I hope you can hear it. So that is simply the finger test. So I'm just pushing here onto the board, and when I find the right connection, then you hear this hum in the speaker, which will be of course amplified here through my audio amplifier, and then you have a first indication what's really going on. So the wiring is good, and most likely here our connections are good as well. So the problem we have must somewhere else. But we know the first, so that is already the first check we can do, and that is something you do not really need good equipment or test tools to do simply this here. Yeah, and the next test is, so do you know what we can do next? Remember our schematic, and remember what we should see at the capsule. Right, we should see finally a DC voltage, and that is what we want to test. So let me switch on the light, and it is easier to see for you. And for this test you only need a very cheap multimeter. And let me go here to the pins and see if we have something here. Come on, that is because I'm working here through my camera. But finally we have 6.1 volt here directly at our capsule. So that means that our voltage supply for our Electret capsule is given. So that is not the problem. So everything is fine. Remember our schematic. So we had the both resistors which were then directly connected here to our capsule, and we said one side is ground and the other is then of course our supply voltage, and now we know our supply voltage is present. So there must be another problem, and I'm still believing, but we will see it in a while, I'm still believing that we have here a problem with our C30. But let's go step by step, that you get an idea how you can check your own microphone, or how you can or cannot modify your Electret microphone. Okay, so what can we do next? So maybe let's have a look on our schematic. Okay, so what we have done so far is we have taken the voltage here directly at our capsule, and that is fine. So that means here our supply is just fine. So now we can of course test here at C30 if our voltage is still there, because that is what we must see. And then we know that our way from the capsule up to the C30 is fine. And yeah, so let's do that. Okay, and so again we have both in view, and let me double check here at our capsule. Yeah, everything is fine. Now we want to test here our voltage at the capsule, and there is and is not. Yeah, and I believe that is already the problem. So depending on how I get here to the lead, and you see I can already move here a little bit the capacitor. So I think we have here a broken wire, or not a broken wire. I believe, yeah, it looks like it is a broken trace down here. So let's see what it is really. Okay, so that is here a better view. And can we? No, we cannot. But oh, have you seen that? Incredible! That is incredible, isn't it? So, unbelievable. So, yeah, I was already guessing that we really have had a problem here with our traces, and you see here are the pads already at our capacitor, and it was here sitting and maybe only connected over I don't know, maybe it was just a little bit where it was combined here somehow with the PCB, but oh my goodness. So that is I cannot get here any closer, but you can easily see the pads are completely off here, and yeah, that is the reason why it didn't work. So it was intermittent here, or not intermittent, it was an open connection here at least, and therefore no contact to be able to transfer any audio signal. So yeah, that's what it is, and that is what very often happens. So if you solder really these components, these through-hole components to SMD PCB, then even when it looks like fine at the first glance, then if you use it in the car, and you have always, you know, if you drive, you have some shocks which will be here transferred to the PCB, and these components are simply not made for SMD for SMD PCBs, and therefore it simply breaks off here from our traces, and the pads are off, and now we simply need to fix it, and yeah, I will see what we can do. I mean, this here is, what is it? It is a 220 nanofarad capacitor, and normally there is, according our schematic or our part list, it is a 1 microfarad capacitor. So this is a modification which has been done here to our board, to the microphone, which yeah, makes the sound a little bit different. You know, this 220 nanofarad setting works great for SSB by reducing the low frequencies and putting more of the mid-range into useful, yeah, at least talk power. And for FM, if you use it for FM, then of course the 1 microfarad capacitor which was in is really a good choice, as it provides more full range audio. And so that is finally the difference. So you may remember you have, let me see, I should have here a Yaesu microphone. So this here is a Yaesu microphone, the what is it, the MH-31. So that is a normal stock microphone, nothing special. But here is a switch on the back, and you can really simple modify this microphone. So you can do both capacitors inside. So for SSB you put in, yeah, I wouldn't use a 220 nanofarad. I think 47 nanofarad is even better, because then you cut even more low frequencies, and that is what you want on SSB for a pileup. And yeah, when you then want to talk on FM, some rack shewing, you switch it over to the 1 microfarad capacitor, and then, as I already said, you have much more full range audio available for FM rack shewing. And by the way, that reminds me on an early video, so that is video 29, where we had an Yaesu FT857 with no TX audio, and the problem was that I'm not entirely sure, but I guess it was a faulty capsule, and I replaced Electret capsule into this microphone and did this modification that you can switch between two audio two audio settings, one with 1 microfarad and the other one with a 47 nanofarad capacitor. So, you know, if you're interested in that, so simply watch video 29, and there you see this modification done on the MH-31 stock microphone from Yaesu. Right, so now with our broken pads here, I need to find a way how to bring in a new capacitor. So therefore I have to use my microscope, as this is really tiny, and I definitely need to find 2 other pads at least where I can put a new capacitor to, and that will be somewhat yeah, it will be somewhat funny. Okay, so what you can see here is that I would have the right SMD part to fit in, and if this part would have been used right from the beginning, then this problem would have never occurred. So now we have really the situation that I cannot really solder this SMD capacitor in, as the pads are gone. And of course I could now go and put some new copper here under it, but you know, that is definitely not the best idea, because we will have all the shocks which you normally have in a car while driving, and I think it is not the best idea to try and fix the pads here with new copper foil or so. So I guess we really need to go and find another solution for this here. Okay, so the best I can do in this case is putting in one of this capacitors. So it is the same value. It is also 220 nanofarad, and the old man was not complaining about the sound, so I believe he is satisfied with the audio. The other capacitor produced in this circuit, so we leave it here with the 220 nanofarad. But as I said, I personally would reduce it to 47. But anyways, that is another story. So maybe this is a good compromise between rack shoeing and SSB DX. Okay, so as we have now here a through hole part with leads, I can bend it, and I can try and solder it here to this point, because this is a nice and strong fixing point at this resistor here. And on the other side we can go and use this little capacitor here and solder it here to this capacitor. Then we have this of course are no pads, but it is a way to handle this damage, and we can use this through-hole components, because we are working here with audio frequencies, so that is no real problem. If it would be HF, then it is definitely a different story, but well, considering it is only audio frequency, we can do it this way. And let's see that I can put one lead here to this resistor and the other one here to this little cap. Okay, and here is as it looks like right now, and yes, you are right, it is really no beauty contest to win, but well, I was able to find here a very large pad which is able to hold this capacitor in together with this little capacitor, so all is soldered together. And here we has taken this little pad from the resistor, so this is definitely more weak, but all in all it is fine, and I will fix the capacitor on the board with some hot glue, and then I hope everything will be fine. But before we do that, we can check if the microphone is working right now. Okay, so that is simple. We take here our microphone cord, put it here back into the socket, and do you hear that? It is working. Great. And feedback as well. Okay, so definitely working. So let me put it back into the housing, minimum this side, so that the capsule itself come back into its place. And if you look here, so that is where it has to go in. And very often the housing and the hole itself makes a big impact on the tone and the audio quality. So therefore you should only put more holes into your microphone, or you should only make the holes bigger when you are sure that everything is fine with your capsule. Otherwise, changing the diameter and putting more in does not consequently mean that the audio is better afterwards. So it could really be the opposite, so it could be worse. So it is really in engineering task for acoustic, where engineers only look and find solutions how to place a capsule together with a housing, and only minimal things which get changed makes a big impact on the audio itself. So it is never easy to drill it bigger or do a second one in and then your sound is better. No, you can really make it worse. So it is really an interesting and challenging task to really design good audio, and not only the capsule, also, you know, the housing itself. Okay, so we have now here some hot glue on. You may see it, so that will hold the capacitor in place. And yeah, now let me close the housing and then we can test the microphone once again. Okay, so work is done. It is all back together, so now we can test it. 1 2 1 2, hola, test, audio test. 1 2 1 2 1 2, that is an audio test. Check 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 check. And I would say it sounds pretty nice. So that means we are really at the end of this video. I hope you got an idea on how to work with microphones, how to troubleshoot microphones, and you got an overview over the different capsules used and the different concepts used, and maybe you are now able to troubleshoot your own microphone a bit, and you have an idea on how to modify the audio, the voice. And well, that is the same with this microphone. Now the old man can test how it sounds on air, and if it not really fits with his voice, we can easily change the capacitor. So as I already said, I would put it to 47 nanofarad, but then maybe it not really fits to FM anymore. Anyways, so that's it for today. Thanks for watching, and if you like it, please give me a big thumb up and catch you next time. Bye.